Welcome to this video. In this video I will demonstrate some concepts of Git and GitHub. So I was actually recording this video and it got corrupted, so I'm recording now. So yeah, this is Said from Toronto, Ontario, Canada. I will just show a simple Git strategy and how to interact with Git and GitHub. So we'll be using GitHub for a remote repository. So let's say I can create one more repository here. So it will create a README file. So we can clone it here. What we will demonstrate actually, I think creating some branches, interacting with those branches, and how to merge different branches with the master, or how to interact with GitHub, how to interact with a remote repository. That's what we will demonstrate. So I think we will be using this strategy, the simplest one, the master branch. We'll be creating feature branch and bug branch. When you want to implement some feature, you can create a branch from the master, and then when you are done with the feature branch, you will be merging those changes into the master. When you want to fix some bug, you can create a bug branch from the master, and when you are done, you will be merging your changes into master, and we will be interacting with GitHub, push and pull, mostly through the master, but we might want to push and pull with the remote repository, just in our case GitHub, depending if other developers will be working with this feature or not, or if they want to see the changes in this feature or not, depending on that. Anyway, this is one of the simplest strategy. And by merging what we told, we want to merge our feature implementation to the master branch. Actually, it will not happen that we will not merge our changes directly into master. What we will do, we will merge the changes in master into feature first, and then we will merge our changes into master. Because as we have remote repository and other developers for the interaction, the master might have some updates there that we might want to incorporate into our feature branch, and let's see if our feature branch works in integration with other changes, and to keep master branch safer. So in this case, we are just going one step further. We'll be keeping master branch always clean and deployment to production ready. In that case, we'll always be developing on the develop branch. In the beginning, we'll be creating a branch from a master, name it develop, and when we'll be implementing any features or any bug fix, and we'll be creating those corresponding branches, and this develop and those feature or bug branch will be merged and those things. And we can also do push pull with the from this branch, depending on the situation on this branch as well. Anyway, the idea is do the development here, and when we want to make something production ready and deploy, then move everything to master and make it perfect and deploy. But Or another thing, I think if you are using the same software for multiple clients and they need custom development, in that case you can create some multiple client branches. So this is client 1 branch, this is client 2 branch, and this actually is the client 1 master branch. This is client 1 develop branch, this is client 2 master branch, and this is client 2 development branch. Now from the development branch we will be creating this bug branch or feature branch. And if we want, for any other reason, if we want to create our version of the software for some other purpose, then we can create another master for ourselves. So client 1 will push from here, client 2 will be pushed from there, and if we need push means I think at this moment the push I mean the deployment aspect. Anyway, so yeah, we created a repo here, and then we did a clone. Let us create. Okay, I told that I'll be using the master and feature and bug first one, but I can go one step further. Develop git checkout -b. Okay, don't make it simple. So you can see your branches, all branches. So let me see, create one file. Okay, we can see it. We want to see what are the files that Git sees and how does it see. What does it say? So untracked file, one untracked file. So if we want that this is the file that needs to be part of the project and we need to track this file, then we have to add this file. So all file in the current directory, all file in everywhere, or you can give the name. So now this file is part of the project that we want to track. Then we can change this file. So we did some change. So we know that this file was modified. We already added. So if we want to remove our changes, then we could do git checkout. So it's empty. Let's see, write something. So it's modified. We can see it there. Now we can commit this file to our repository. By committing, we mean that whatever changes we have made, we do not want to lose it, and we want to make these changes part of our repository. This is the changes that we are kind of confirmed we want to keep. The situation might change after, but for now we want to make these changes part of our repository. Git commit current directory all, or we can give the name of the file, and this comment on the commit, use a meaningful one. meaningful message will help. So git status, we are up to date, everything is clean. .txt, .txt. So we can add them. I'm adding everything. So I can commit. Okay. Previously we used this message here, and we also give the file name. Still, if you do not give the file name, it will include all file, and -m you can provide the message, or you can just do it like this. Then it will be using some sort of editor. Now it's vi escape write q. Okay, we can see our log history here, git log. Now if we see at the remote one, nothing is there because we did not push anything from our local to there, and it does not have that branch here. Now this is a merging time, right? If it is a merging time, we told that we will merge our branch with the master branch first, then we will go to master branch, we will switch to master branch and do corresponding merging or adjusting with remote as well. Let's say before merging, depending on the situation, you might want to use git fetch. So we are fetching objects and references from repositories, from other repositories. I think in our current case, we actually do not need to fetch. Just as a practice, we did it. You can do all objects from all repositories fetch, depending on this branch. Fetch just downloads, but it does not merge or does not change your files. So now we will be doing a merge. So we will be merging with the master. Anyway, because I think sometimes this merge might have some conflict if the changes, our this feature branch change and the master branch changes were different. There could be some merge conflict. In that case, you had to fix those things. I think after fixing those, you could commit one more time, merge commit. That could be git merge tool that you can use, or you can just use some editor to fix those changes and incorporate the changes appropriately, and then I could commit. Anyway, we are going to master. We do not have any of the files. Let's say at this moment we have nothing to pull from the remote, but as a practice you can pull from the remote first before merging into the feature branch, just so that making everything consistent. Then git pull will work. Git pull origin master. This is more specific. Git pull origin master, but nothing is there, nothing is brought up into now. Okay, I want to keep an eye on this thing. Sometimes it freezes. Git merge, no fast forward. It just ensures that there will be a merge commit. Actually, this if I don't use it, it will be just merging, but no, without commit. But if we use it, it will act like a commit and it will create one more commit. So at this moment, let's say there is one commit here in the git history. I did not execute that merge thing yet. So you can see so this commit merge branch feature branch, yeah, there was a commit merge commit. Okay, now where we can go, we can push our changes to the remote repository. So we don't have the branches. We can just git push will work if the mapping is done already, or git push origin master, being more explicit. But still the feature branch will not show up on the remote because we are pushing from master branch. Let's see. So we don't see the branch there. Git checkout feature branch. We can also push this. In that case, this feature branch will be pushed to the. So here in it, more explicit, git push origin. Yeah, we are using a little bit different command than they showed. Yeah, the one that showed, it is just to make the upstream, the remote feature branch and local feature branch aligned, so that only git push will work. But the one that I am using, it does not ensure that. I'm just explicitly pushing. Next time I also have to push explicitly. We might need to use a little bit different format depending on the version, but looks like it worked. So feature branch is there. Let's say git push, yeah, because we did not map it, so it will not, just git push will not work. So what we can do, we can so we are just making the link. Now if we say git push, so it knows feature branch has to be pushed to feature branch. Anyway, we did push, and some of the workflow in the feature branch, let's see, you are off for some day now, someone else has worked on the feature branch on the remote. Now you are back, you want to work with the feature branch, you need to pull from feature branch and then you can work on it. You can just directly use git pull command, that will work. Git pull origin feature branch, that will also work. And there is one another, you can use git pull rebase. What will happen, it will pull from the remote and it will make the commit history more easily readable by making some linear history. Actually it has to do with the remote branches, interactions with other branches. It has something to do with this, but for now you can use git pull rebase as a good practice, and I can explain in another video how this rebase actually works. So yeah, you can do the git pull rebase and then work on it. Okay, now one another way, we can use in push command as well. I think before pushing our changes to the remote, we can do a git rebase to make the history linear and more consistent. Git status, git commit -m push rebase demo. So we have committed here. Ideally the tree representation will make more sense. For now let's execute those commands, and then so before pushing to the remote feature branch, we are not merging with the master because we are just thinking we are not ready there, we are not there, but we want to make sure that other developers can see our changes. So we'll be pushing. So before pushing, we can use git rebase. Git rebase might have different commands like interactive or squashing. The changes will be on the feature branch. Okay, that is the workflow to some extent. Let's see, you can see git rebase, how that works. In the git documentation there is some good examples. Let's see how the git merge work. Let's say when you created your branch, feature branch, you created it from here and then you made some changes, and currently you are there, right? You are committed all of your changes and you are there. and in the meantime the master has proceeded to some extent. Now if you do a merge, what will happen? I'm just trying to explain merge and rebase. So everything will be merged and master will be there. So in that case you'll be able to delete this. And merge conflict, when there is a merge conflict, it will show conflict like this. Then we use the merge anyway. So at any point if you want to see the merge where the merges are, you can use git status and it will show. Then you can open notepad or something else, or VI or Nano, and I think head portion will show that code from the branch you opened, you tried to merge. So when you are on feature branch and we executed git merge, then this will be from the feature branch and this will be from the master branch, provided we are merging with the master. So if we want to keep everything, just delete this and delete this. We just have to see whatever the changes we want to keep. After keeping, we can save those files and we can commit, and merge commit is done. Or we can use git merge tool to see the differences and for committing. Okay, let's see. So you created branch from here and experimenting here, and let's say we did some commits. It's not C4, it probably C5, 6, 7, 8 somewhere you are here, and master is also proceeded here. Master, it can be somewhere here. So I think this is the merging to integrate diverse work history. So if you merge, so this is how it is being merged, and you can delete this part. Now if you want to rebase, let's say git checkout experiment. So we are on the experiment branch, and we want to incorporate all the changes on the master to our branch, and with some rebasing. So if we git rebase master, I think there will be some, at every commit, all the changes in masters, they will be kept in temporary files, merging and applying and then patching, and it will be after this. So getting the diff by each commit, I think for all of the commits that we did, so all the diff will be there, saving those diffs to temporary files, resetting the current branch to the same commit as the branch you are revising onto, and finally applying each change in turn. So what it is doing, so it will try to find out the difference introduced by each commit of the experiment branch. So find out the difference in each commit of the experiment branch. Difference means the difference that you introduced, whatever the changes you have made. They will put these changes into a temporary file, and then it will reset the current branch, that means experiment branch, to the same commit as the branch you are revising onto. What does it mean? It will reset these commits to the commits of master branch, and then apply all of your changes in turn. So yeah, and then you have to git checkout master and git merge experiment. In that case, you are just in this state. Actually, the issue is here because when you are working on it, the master has already proceeded, right? The master has already proceeded. When you are here and you are doing your experiment, not here, I think the situation is here. You are here, but and you are doing experiment. In the meantime, master has proceeded with other changes, probably good ones, but you are behind. Now, rather than incorporating your commits in between, why don't you incorporate all those changes and make your experiment, the head of your experiment, not here but from forwarded. So that's why what they are doing, when you are rebasing, all of your changes in each commits, those are saved into temporary files, and your commits, I think the commits in the masters are being integrated, and finally your changes are being integrated. Let's say, so what it is doing, getting the difference introduced by each commit of your branch, then saving those differences or your changes to temporary files, and resetting your branch, that means experiment branch, with the commits of master branch, and then applying your changes. And then in going to the master branch, if you merge experiment, then you are in a good condition. It will make your history to look linear and consistent. It will make more sense. Okay, that's a little bit complicated scenario. Okay, what else I wanted to show? Merging, rebadging. Okay, merge, I showed how merge works, and then rebadging, how this work. And another thing is rebadging. Many companies might not want to use rebadging. Okay, let's stop here. I might come back with another video, Git successful branching model. This one, or I might show different Git concepts. Anyway, bye bye.